Absolute value inequalities. Well, I think we should be familiar with absolute value, and it says, recall that absolute value is the distance from zero, and that a distance must always be positive. So let's just look at this first one. The absolute value of x is less than 4. If I ask you to give me numbers that make this true, well, you would start, well, you can't say 4 because it's less than, but you could say, I didn't mean to make that mark there, you could say 3.9 and 3 and 2 and 1. So these numbers less than 4 make it true. Now, can I keep going forever? Well, what happens when I get here to negative 5? Put negative 5 in for x. The absolute value of negative 5 is positive 5. So I can't go past this negative 4. So I can graph in between them. Does that look familiar? That looks like an AND problem from the previous assignment called compound inequalities. So basically, these are compound inequalities in disguise a little bit. So let's just look at the other one. I'm going to show you how to rewrite them into a form that looks like the kind we already solved. So for this one, if I said, give me numbers that make this true, the absolute value of x is greater than or equal to 3, you can say 3 because it has or equal to. And all of the numbers to the right of it. Now, is that all? What about negative 3? The absolute value of negative 3 is positive 3. I can fill that in. And negative 4. The absolute value of negative 4 is positive 4, which is greater than or equal to 3. Looks like it does that. That looks like an OR problem. Okay, well, here we go. Let me move this up. So anytime a problem is less than or equal to, like this first one, that's going to be an AND problem. Here's a little memory trick that I did not come up with. Less than, maybe call it less than, okay? If it's greater, maybe think of that as great or, okay? Great or, that's an OR problem. That's the best way to maybe do that unless you can just remember it. So what this explains here is how to rewrite it. And it's kind of hard to maybe decipher some of that, so I'll just show you. Okay, going back to the first one, first of all, I have to read it and understand that's an AND problem. So if it's an AND problem, I just copy what I see up here without the absolute value. I use the same symbol on this side of x, but here I don't write 4, I write the opposite of 4, negative 4. That's exactly what I have graphed there. This looks like the first 3 problems on your assignment, everyone. There'll be a big space like this to rewrite it, and then there'll be a number line. Now I'll show you the assignment. And don't check out of this video early. It's going to be a long video because I have to show you ones that look like some homework problems. If you right away say, oh, I see what you're doing, and you jump out, you're going to be lost. And people are sending me assignments where they're doing work that doesn't even look like anything I ever showed you. I am not giving credit for that. Okay? But people say, yeah, but I tried. Yeah, but it's not at all what even makes sense in mathematics. So don't bail is the message there. Well, anyway, so for the OR problems, how do I know it's OR? The absolute value of x or all numbers great or than. So again, I copy what I see without the absolute value. I write the word OR. Now watch what I'm about to do. I write x again, but I flip this over. I'll move it over too. Less than or equal to, not 3, negative 3. That's what I have here. All numbers greater than or equal to 3, or all numbers less than or equal to negative 3. Okay, well, I think we have to just jump in. I have 2 on the bottom of this page. There are 4 on the back. So maybe you might have to pause the video and take a break. Go get a refreshment if you need to. So, step 1, you look to see if there's any numbers on the, like, here's our symbol, right? Any numbers like over here that are being multiplied, maybe being added over here. We want to make sure the absolute value is all by itself. And it is. So I'm ready to rewrite this. Okay, don't start solving. Maybe I shouldn't even have drawn that. Don't do plus 4 plus 4. I need to rewrite it. Okay? So I'm going to rewrite it as And or, let's see. Less than. This is an and problem. So I'm going to write x minus 4 less than or equal to 8. So it's just a straight copy. Put your same symbol over here and make this the opposite of that. Negative 8. Now I can solve. Okay, I want x by itself, plus 4, plus 4, plus 4. That's a 12. X is by itself. That's a negative 4. Again, if you're trying to figure out how to go from negative 4 to 12, remember, count by 2s, count by 3s, count by 4s, count by whatever you want to make it fit. I'll count by 4s. That'd be negative 4, 0, 4, 8, 12. X is in the middle, so I'm going to graph. In the middle, close circles. There you are. Okay, so I'll just go back up here for a second. Look at the steps. Isolate the absolute value. That's what I mean. Make sure it's all by itself. Then rewrite it. Then solve and graph. Don't worry about this step. We're not going to write interval notation. Okay, so the next one, great or. That's an or problem. So it's just x plus 2 greater than 9 or x plus 2 less than. See, I flip it and I change the sign of that number. And now I'm going to solve each one. Minus 2, everywhere in fact. Don't do minus 2 up here. That is the biggest mistake in this topic. Okay, so what do I have here? X is greater than 7, or x is less than negative 11. So I have to make it from negative 11 to 7. And don't worry if you're not quite on a whole number. You can graph in between. Just draw a circle in between. So how would I do this one? I'll put negative 11 here. Maybe I'll count by 4s again. There's negative 7. There's negative 3. Positive 1, positive 5, positive 9. So 7's not going to show up, but that's okay. All numbers less than negative 11 or all numbers greater than 7, just go in between where you think it will be. It's okay to do that. And things like that happen. Okay, I told you this video was going to be long. Is it break time for you? Okay. Now, isolate the absolute value. Hey, I'm doing this. You'll be successful on the assignment, by the way. The absolute value is not isolated. I see a minus 2. So I'm allowed to do this first. Add 2 to both sides. See, first step, isolate. So this is still set. Oh, that should be a minus. Why do I use a pen when I do this? Okay, that'll be greater than or equal to 11. Now I can rewrite it. And I rewrite it, it's an or problem, great or. So it's 3x minus 1 greater than or equal to 11, or 3x minus 1 less than or equal to negative 11. Okay, so I'm going to solve, add 1, divide 3, x is greater than or equal to 4. Or I solve the same way. I add 1 to both sides. I'm getting a different answer because I have a negative 11 here instead of positive 11. Less than or equal to negative 10. And this one doesn't divide evenly. Oh, yay. Yours on the assignment will. Less than or equal to negative 3 1/3. All right, I can handle that. So I'll just go with negative 3, negative 2, negative 1. It fits. Greater than or equal to 4 goes to the right. Less than or equal to negative 3 1/3. I'm just going to go to the left of negative 3. It's over there somewhere. See, it's in between negative 3 and negative 4. That number there. Okay, again, yours all divide evenly, so I don't think you have anything to worry about related to that. Okay, now you have on the assignment, it looks like this. Let's first get the absolute value by itself. And can't you see we're going to do minus 5, then we're going to divide by 2, divide by 2. So that's what all this space is for. So this still looks like That I have not isolated it yet. So now I'm going to divide by 2, divide by 2. Now it is isolated. There is absolute value of x plus 3 less than 3. I'm still a little crowded here, but I have to rewrite that. Less than, that's an and problem. Actually, I'm going to go underneath this line because it's too crowded. X plus 3 less than 3. I write the same symbol, and I just write minus 3 there. This one will solve very quickly. All right, I got two symbols now. I minus 3, minus 3, minus 3. That's a 0. X is by itself. That's a negative 6. So negative 6, what am I going to count by here? Maybe by 2's. Would that work? Negative 4, negative 2, 0, 2, 4, 6. It will. I could have counted by 3's also on this one. Oh, wait. I'm only going to 0. I was fine. I thought I was going to 6 for a second there. So in between 0, negative 6 with open circles. Finally, if you want to try these two on your own, go ahead. But I am going to do them. Yeah, we're at 11 minutes. This is the longest video I've ever made. I hope you're still with me. Isolate the absolute value. 2x minus 13, well, absolute value of, less than or equal to negative 1. Now I can rewrite it. Less than, that's an and problem. 2x minus 13 less than or equal to negative 1. Same symbol. Put a positive 1 there. Okay, so to get x by itself, it looks like 2 steps. Add 13. I did. That's 12. That is 14. Divide everything by 2. That's a 7. And that is a 6. When I go to graph this, this is actually an empty set. You're not going to have to worry about this. Yours are all going to graph. But I changed this problem, and that's what happened. So I have 6, I have 7. All numbers greater than 7 are all numbers less than 6. There is no number that is both. So these are the, every once in a while this will happen. This will not happen on your assignment. Okay, they will graph. You will see x will be in between two numbers. So let's just do this last one and see what happens. Isolate the absolute value, minus 5 on both sides. I changed this one too, so we're going to find out. Okay, so great or 3x plus 9 greater than 6, or 3x plus 9 less than negative 6. Minus 9 on both sides. Divide by 3. Minus 9 there. Divide by 3. All right, so negative 5. Count my way to negative 1. All numbers greater than negative 1. Or all numbers less than negative 5. Okay, the assignment is exactly what I just did. Again, if I put a little star, you're going to have to divide by a negative. That one will flip. If you have any questions, let me know. This is not one of our easier topics. Okay, everything should work out though. Remember, and problem should graph in between. You don't have to use every little mark on this number line either. If you want to jump over, like for instance, if that's 7, you could skip 1 and write 8. You could skip 2 and write 8. As long as you skip 2 and write 9. Keep it consistent. All right, let me know if you need any help.